Hi there. Let's talk about 2.53. So this is based on actual data for the 2004 high school graduating class. So of the 1,171,460 students that took the ACT in that graduating class, 1,052,490 of them scored a 27 or lower. So we know from the data that the mean ACT score was 20.9, the standard deviation was 4.8. So let's see how well the normal distribution actually fits the data. If we assume, if it is given to us that the data are normally distributed with this mean and with this standard deviation, what percentage of observations would we expect at a 27 or below? So we're calculating here the percentile. So notice here's the picture. Here is my normal distribution. The mean is labeled as 20.9. I've labeled the standard deviation as 4.8. So an observation of 27 would be a little more than one standard deviation above the mean. So I've put that here, and I'm interested in the shaded area. I am interested in determining the proportion of scores that are at 27 or below 27. So first of all, I need to take that 27 and turn it into a z-score. So 27, take away the mean of 20.9, divide by the standard deviation of 4.8. That gives me a z-score of 1.27. So notice if I look at my shaded area then, the 1.27 is the right boundary of the shaded area. The left boundary I'm going to use a negative 10 for my z-score on the left. So let's go ahead and do that in the calculator. So make sure that you have cleared the drawing off of your calculator, so you should be on the home screen like I am. So just to review how to do that, you have to press the second button and then the program button and then enter twice, and that will clear the drawing. I'm going to clear the home screen again. So to do this calculation, I'll press the second button, the variables button. I'll press the right arrow to go over to draw. The shade norm command is what I want. I'm going to enter the z-scores and it is going to give me the percentage, and in this case it really is a percentile. So my lower boundary should be negative 10 and the upper boundary should be the z-score that we calculated, the 1.27. Again, since we're working with z-scores, z-scores have a mean of 0 and a standard deviation of 1. So you don't have to change those values. I will go straight to draw. I should have already set the correct window. I did. So very good. This screen on the calculator here gives me an area of 0.898. And again, that picture corresponds to the picture that I drew. So the area under the normal density function is 0.898, and that represents 89.8% of observations. So a 27 or below, that area is representing this percentage. 89.8% of students would have scored at a 27 or below. That's also a percentile because I'm finding the percentage at 27 or below 27. So what's interesting about this question then is you're asked to actually look at the percent of the actual ACT scores that were 27 or below. So I've already done that up here. So if you take the actual number 1,052,490 and divide by the total number of students that took the ACT, 1,171,460, the actual percentage, once again, is 89.8%. So this question is asking you, does the normal distribution describe these actual data well? So at least in this one particular case, in terms of this one calculation, I'm afraid given the data that we have, yes, because these percentages are close, in fact, they're, for all intents and purposes, they're identical, the normal distribution does appear to describe these data well. So without having more information, without having more of the data so that we can really look at the shape and make sure that the mean and the median are similar, make sure we have a symmetric distribution, or without being able to check how well the data follow the 68, 95, 99.7 rule, we really can't say a whole lot more. But at least based on these two calculations, the normal distribution is a pretty good approximation to reality.